Have you done the yesterday's question?
Yes, ma'am.
Is there any doubt?
No, ma'am.
I will do this question for clarity. So if you have any doubt, please ask. So in this question, we have to find out the R0 value. What is R0? Please respond. What is R0?
0.75.
Can you repeat?
Net reproductive rate.
It is the net reproductive rate and it is given by sigma Lx mx. So in this table, firstly we have to find out nx and dx. So here we have this 1000. How to find out this dx? Anyone?
Nx minus nx plus 1.
Okay. So nx minus nx plus 1, that is 1000 minus 800. So we will get 200 here. And here what will be the value? In order to find out nx in the third age class, we have to add this 300 and 200.
500.
So here it will be 500. Then we can find out the dx in second age class. How to find out dx in second age class?
$500 minus $200.
No,
800 minus 500.
800 minus 500. It is the right answer. In order to find out the equation is nx minus nx plus 1. So considering second age class, nx is 800 and nx plus 1 is 500. So we can easily find out dx, that is 800 minus 500. So here it will be 300. Now we want to find out nx in the last age class. How to find out nx? We have 300. We have 300 individuals in the fourth age class. Of these 300 individuals, 100 individuals have died. Then there will be remaining 200 individuals. Is it clear?
Clear.
Then we want to find out. Hello, is there any doubt? No. Okay. Then we have to find out age-specific survivorship. That is LX. How to find out LX?
nx by n. nx by
So Lx is given by nx by n0. What is the value of n0?
1000.
So for the whole table, n0 is 1000 and nx will change. So for the first age class, the value for Lx is 1000 by 1000, that is 1. Then for the second age class, it is 800 divided by 1000. So it will be 0.8. For the third age class, it is 500 divided by 1000. So it will be 0.5. Then considering fourth age class, nx is 300 and n0 is 1000. So 300 by 1000, 0.3. Then last age class, 200 by 1000, that is 0.2. Is it okay?
Okay, ma'am.
In the table, they have given mx values also. So we just multiply Lx with mx. So for the first age class, Lx mx is 0. Second age class, it is also 0. Then third age class, 0.25. Fourth age class, 0.3. Fifth age class, 0.2. Then for finding out R0 is sigma Lx mx. So we have to add on these values. It is 0.75. So first option is the right answer. Is it clear for everybody?
Yes, ma'am.
Yes, ma'am.
Does anybody want to repeat? Okay. So life tables and demography chapter is over. Then considering population ecology, one more chapter is there. That is population growth. So there are three models of population growth. First one is geometric. Second one is exponential. Third one is logistic. These are the three models of population growth: geometric, exponential, and logistic. Of these, geometric and exponential growth produces J-shaped population growth curves. Geometric and exponential growth produces J-shaped population growth curves. And logistic growth produces sigmoid curve or S-shaped growth curve. These geometric and exponential growth models consider resources are unlimited. So in the case of geometric and exponential growth curves, graph will be like this. So this graph is increasing like this because they consider there is unlimited resources. There is no scarcity for resources. Resources are unlimited. So population can exhibit unlimited growth. This is the peculiarity of geometrical and exponential growth. Geometrical growth is exhibited by periodic breeders. Do you know what is periodic breeders? Periodic breeders exhibit geometric growth. Periodic breeders mate during certain times of the year. So that times are best for the survival of their young ones. They are periodic breeders. So geometrical growth is exhibited by periodic breeders. Periodic breeders are nothing but they mate during certain times of the year, and that times are best for their for the survival of their young ones. Example for periodic breeders include dogs, birds, etc. So there is also an equation for finding out the population size of geometrically growing population. That is nt is equal to n0 into r0 raised to t. This is the equation for finding nt is population size at generation t. N0 is the number of females. And t is the number of generation. So this is the equation for finding out population size of geometrically growing population. Nt is equal to n0 into r0 raised to t. What is r0? Hello, what is r0?
Net reproductive.
Net reproductive rate. So in order to find out r0, we have to find out the values of lx and mx. So because of the effort involved in calculating this r0, some ecologists use a shortcut. So we have another term that is lambda. This lambda represents finite rate of increase. Finite rate of increase is the ratio of population size from one year to the next. It is the ratio of population size from one year to the next year. This N0 is the population size at first generation. N1 is the population size at next generation. So the ratio of population size from one year to the next is finite rate of increase. For example, we can take N0 as 100. And N1 is 105. This is just an example. So in order to find out finite rate of increase, we have the equation lambda is equal to N1 by N0. So here N1 is 105 and N0 is 100. So we will get 1.05. This is the finite rate of increase, that is ratio of population size from one year to the next. Is it clear? Finite rate of increase.
Ma'am, once again repeat the what is N1 and N0?
N1 is the population size in next generation. N0 is the population size at first generation.
N1 first 1 year then, ma'am.
N1 is the population size at first next generation. At initially there was 100 individuals. In the next year it was increased to 105. So 100 here N0 indicate population size at the initial generation. And N1 indicate population size in the next generation. Is it clear?
Ma'am, N0 means population or overall population.
No, population size in the initial generation, first generation.
Okay.
Using this lambda value, we can also find out the population size in the future generations also. So for that, we have another equation. That is nt is equal to n0 into lambda raised to t. Do you remember the previous equation for finding out population size of geometrically growing population? It was nt is equal to n0 into r0 raised to t. We are substituting this lambda because of the effort involved in finding out r0. So we are just replacing this r0 with lambda. Is it clear? So in the previous example, N0 was 100 and N1 was 105. We can find out population size after 5 years. So we have to find out N5. that is N0 into R0 raised to T. Here T is 5. So N0 is 100. Sorry, not R0. Instead of R0, we are substituting lambda. So here lambda value will be 1.05. After doing this equation, we will get 127.6. So this is the population size after 5 years. So this equation is used for finding out population size after some time interval or after in the future generation. Is it clear? If you have any doubt, please ask.
Hello, Miss Periodic Breeders.
Ah.
Once more.
Periodic breeders എന്താണാണോ?
അതെ.
Periodic breeders എന്ന് വെച്ചാൽ ചില സമയത്ത് മാത്രം ബ്രീഡ് ചെയ്യുന്നത്.
ഓക്കെ.
കണ്ടിന്യൂസ് ബ്രീഡേഴ്സ് ഇനി വരുന്നുണ്ട്. അത് അപ്പോൾ എക്സ്പ്ലെയിൻ ചെയ്യാം. Can you see the screen? Is it visible now?
Yes, ma'am.
So there are two life history strategies. Before explaining that two types of population growth, I am explaining these reproductive strategies. So there are two types of reproductive strategies. They are semal parity and heteroparity. This is semal parity. Semal parity means when offsprings are produced in a single reproductive event, it is called as semal parity. So these semelparous organisms reproduce only once in their life cycle. After reproduction, they will die. So example for semelparous organisms include this yucca plant. Can you see this plant? This is the yucca plant. Another examples include bamboo grass, insects, salmon. These are examples for semelparous organisms. They will reproduce only once in their life cycle, and after reproduction, they will die. So, in the case of semelparous organisms, offsprings are produced only in a single reproductive event. Is it clear?
Yes, ma'am.
And second type of reproductive strategy is heteroparity. This is heteroparity. So heteroparity means the pattern of repeated reproduction. It includes repeated reproduction at regular intervals and throughout their life cycle. But in the case of semal parity, there is only one single reproductive event. But in the case of heteroparity, there is a repeated pattern of reproduction at intervals throughout their life cycle. And heteroparity can be classified into two. It is seasonal heteroparity and continuous heteroparity. First one is seasonal. Second one is continuous. In the case of seasonal heteroparity, they have distinct breeding seasons. They will reproduce only during that particular breeding season. Example for seasonal heteroparity includes birds. Birds are an example for seasonal heteroparity. In the case of continuous heteroparity, they will reproduce repeatedly throughout their life cycle. In seasonal heteroparity, there is no repeated reproduction. They will reproduce during particular breeding seasons only. But in the case of continuous heteroparity, they will reproduce repeatedly. Examples, chimpanzee and mammals. You can understand these from these red dots. So consider this yucca plant. In the case of this yucca plant, it is the birth time, and reaching their death time, they will reproduce. So throughout their life cycle, they have reproduced only once. That is semal parity. Now consider seasonal heteroparity. You can see there is a pattern. They will reproduce only during particular seasons. And in the case of continuous heteroparity, they will reproduce repeatedly. There is no more patterns. Is it clear?
Yes, ma'am.
So this geometric growth is exhibited by periodic breeders. Periodic breeders means they will show seasonal heteroparity. They will mate and reproduce during particular seasons of the year. They will exhibit geometric growth. And in the case of continuous breeders, they will exhibit exponential growth. Is it clear?
Once more, சொல்லுங்க. Miss, once
Hello?
more.
Reproductive strategies are of two types. That is semal parity. First one is semal parity. And second one is heteroparity. When offsprings are produced in a single reproductive event, it is called as semal parity. Consider this as the lifetime of an organism. So this point indicates its birth and this point indicates its death. During this time interval, it reproduces only once. And after this reproductive event, it fall into death. So in the case of semal parity, offsprings are produced in a single reproductive event. They will reproduce only once in their life cycle. Is it clear? Semal parity. Hello.
Clear, miss.
Example for semal parity includes yucca, bamboo grass, insects and salmon. Then coming to heteroparity, there is a repeated reproduction. So it is the pattern of repeated reproduction at intervals throughout the life cycle. So consider this as the life cycle of an organism. So in the case of heteroparity, there is repeated pattern of reproduction. And this heteroparity can be classified into two. It is seasonal heteroparity and continuous heteroparity. And seasonal heteroparity have distinct breeding seasons. They will reproduce only during that particular season. Do you know the case of birds? They will reproduce only during some particular seasons of the year. So birds are an example for seasonal heteroparity. And coming to continuous heteroparity, they will reproduce repeatedly throughout their life cycle. There is no seasons. They will reproduce repeatedly. Example for continuous heteroparity includes chimpanzee and mammals. Is it okay?
Yes, ma'am.
Yes, yes, miss. മിസ് നേരത്തെ ഇതില് എക്സ്പോണൻഷ്യൽ ഗ്രോത്ത് ഏതാ ജോമെട്രിക് ഗ്രോത്ത് ഏതാന്ന് ഇങ്ങനെ പറഞ്ഞില്ലല്ലോ ഓരോന്ന്, അതൊന്നും കൂടി ഒന്ന് പറയൂ. അല്ല ഈ യൂക്ക പ്ലാന്റും ബേർഡ്സ് ചിമ്പാൻസിയിൽ അതിൽ ലാസ്റ്റ് പറഞ്ഞ അത് ക്ലിയർ ആയില്ല.
These birds exhibit geometric growth because they are seasonal breeders or periodic breeders. So periodic breeders exhibit geometric growth. In the case of chimpanzee and mammals, that is continuous breeders, they will exhibit exponential growth. Is it clear?
Clear, miss.
And these growth exhibit J-shaped curves. Both of them result in J-shaped curves. And there is an equation for finding out the population size of geometrically growing population. That is nt is equal to n0 into r0 raised to t. And this r0 can be substituted by lambda. Then the equation becomes nt is equal to n0 into lambda raised to t. What is this lambda?
Finite rate of increase.
Finite rate of increase. So it is the ratio of population size from 1 year to the next year. That is n1 by n0. So you can use an equation for finding out the population size in the future generation. That equation was nt is equal to n0 into lambda raised to t. So that's all about geometric growth. Then there is an equation for finding out the population size of exponentially growing population. That equation is, so now we are discussing exponential growth. So the rate of change of population size of exponentially growing population is given by dn by dt is equal to Rn. This dn by dt is the rate of change of population size. R is the instantaneous growth rate. Instantaneous growth rate. So this R is for exponential growth. Exponential growth, we know that it is exhibited by continuous breeders. So there is a growth in the population size in every instantaneous growth rate. There an increase in the population size in every instant because they are continuous breeders. So this equation is important. dn by dt into Rn. R is the instantaneous growth rate N is the initial population size. Is it equation is clear for you?
Yes, ma'am.
This R is given by another equation. R is equal to B minus D, where B is the birth rate. B is the birth rate and D is the death rate. Birth rate is given by number of individuals born divided by total number of individuals. Divided by total number of individuals. And death rate is given by number of individuals died. Divided by total number of individuals. I will repeat once more. For finding out the population size of exponentially growing population, we have one equation, that is dn by dt is equal to Rn, where dn by dt is the rate of change of population size, R is the instantaneous growth rate, N is the initial population size. And this R is given by another equation, that is B minus D, where B is the birth rate and D is the death rate. In order to find out birth rate, we have number of individuals born divided by total number of individuals. And for finding out the value of death rate, we have number of individuals died divided by total number of individuals. Is it clear?
Yes, yes.
Hello? There is an example showing birth rate and death rate. So this is an example for birth rate and death rate. So here we have a cockroach population. Initially, there was 1,000 individuals of cockroaches, and there is a birth of 100 cockroaches. So in order to find out birth rate, we have number of individuals born divided by total number of individuals. So here we have 100 individuals born and total individuals present in the population was 1,000. So the birth rate is 100 divided by 1,000, that is 0.10. Is it clear?
Clear now.
Also, this is the death rate. So consider same cockroach population. There was 1,000 cockroaches present in the population and 50 individuals are died. So death rate is given by number of individuals died divided by the number of individuals. In this case, it is 50 divided by 1,000. So death rate is 0.08. Okay.
Okay, ma'am.
Then when all the conditions are favorable, this R value will be R max. Instantaneous growth rate will become its maximum level. So then R value will be R max. And this R max is called as the intrinsic rate of increase. Intrinsic rate of increase. Then dn by dt can be written as R max into n. This happens when all the conditions are favorable. In this case, R max will always be a positive number. When all the conditions are favorable for the growth of the population, R value will be R max, and R max will always number